Okay, so we're going to work through the 2020 A-level Maths Paper 2 for AQA, and AQA's Paper 2 is all about pure and mechanics, so let's get underway, shall we, with question number 1. Okay, so we've got, which of these functions is decreasing for all real values of x? Now, it is all real values. So, okay, let's have a think about this then. Now, because we're looking for all real values, the only one that's going to be decreasing is going to be looking at where the derivative, so i f prime of x, is going to be less than 0. The only way where that's true is where this is less than 0. So I'm going to say it's the third one here. And I believe that's the right answer. Which of the following equations has no real solutions? Okay, so we need to be looking for which one of these doesn't work. And the one that doesn't work here is the last one, because we know that sec x is 1 over cosine x equals 0. If you multiply it by the cosine x, you're going to get 1 equals 0, which is, of course, rubbish. Hence, it's the last one, which has no real solutions. You can check the other ones for why they work as well. The third one is a modulus. Log of x, it can be equal to 0. If you exponentiate both sides, you get a function there that x will be equal to e to the 0, which will be 1. And if cos x is 0, then that's going to be 1 over tan x equals 0. That will have solutions. So it's definitely the last one without a doubt. The third one, find the coefficient of x squared in the binomial expansion of 2x minus 3 over x to the power of 8. Okay, so that is literally just 2x minus 3x to the minus 1 to the power of 8, which is x to the minus 1 lots of 2x squared minus 3 to the power of 8, which is x to the minus 8 times 2x squared minus 3 to the 8. To get the x squared, we want the coefficient of x to the 10. So we need to look at 8 choose 5 of 2 to the 5 times minus 3 to 3. Make sure you put your numbers in brackets, otherwise you're going to get the incorrect value. And that's going to get you what? Minus 4, 8, 3, 8, 4 here. And that's the coefficient as required. Okay. Question 4. Use small angle approximations to show that for small non-zero values of x, the x tan phi of x over cos 4x minus 1 is approximately some a. Okay, so small angle approximations, we should know these by now. That's going to be that tan 5x will approach 5x. This is going to be x times 5x. Now, cos of 4x is going to be 1 minus x squared over 2. So that's going to end up becoming 1 minus 8x squared minus 1. Because of the cos x double angle formula, which is going to come via 1 minus x squared over 2. There. Okay, so just need to tidy that up. That's going to get me minus 5 over 8, which is equal to a. Alright, so just using small angle approximations there, tan of 5x will be 5x, and cos of 4x will be 1 minus 4x squared over 2, so which is 16x squared over 2, which will be the 8x squared as you get there. Okay. Moving on to question number 5, integration by substitution on this interesting function here. We are not told the substitution to use, however, I would pick the substitution for 4x plus 1. If you've done enough of these, you will know why. I find du by dx, that's step number 1, as always. And then I get a rearrangement for that x out the front there, which is going to be a quarter of u minus 1 there. So my integral, I also need to change my limits, because I cannot have u limits with x limits. So when x is 6, what's u going to be? Well, that's going to be 20... What's that going to be? 25? Yeah, 25. And when it's minus a quarter, you will end up becoming 0. We've now got an integral between 0 and 25 of a quarter, u minus 1, just summing everything in, times by u to the half, a quarter du. Okay. So it probably makes sense to factor out 1 over 16 here of the integral between 0 and 25 of u to the 3 halves minus u to the half du, which is 1 over 16, just integrating term by term now. That's going to be 2/5 u to the 5 halves minus 2/3 u to the 3 halves, evaluated between 0 and 25. That's just a case of subbing everything in and proving that you get 875 over 12, making sure you sub in the top limit first and then the bottom limit. And if you do that, you're going to get that minus 0. So, of course, you just get the 875 over 12 as required. Okay. Okay, question number 6. We are slowly working our way through these here. Okay, I usually draw a diagram for these. I'm not going to, I'm just going to jump straight in by rearranging this into y equals mx plus c, because we don't like this form a lot. So it's going to be what, minus 12 over 5x plus 298 over 5. I don't like it in that horrible form it gives you in. So we've got the gradient here already. So the gradient will be minus 12/5, won't it? Yeah. Now the equation of a circle we know is x minus a squared plus y minus b squared equals r squared. So the gradient, which will be the derivative of that. So we actually need to find the derivative of x minus a squared and y minus b squared set equal to 0. That's what we need to find here, don't we? So we've got 2x minus a plus 2 y minus b times by dy by dx equals 0. So the gradient function is a minus x over y minus b, which will be the gradient of the tangent, and it's got that coordinate there that we're told, so it's going to be 7 minus x over y minus 9, because we're told that it goes through 7, 9. So we've got 7 minus x over y minus 9 equals minus 12 over 5 from the first bit, which is going to be minus 73 is going to be minus 12y plus 5x. If we solve the simultaneous on our calculator, we get solutions of x equals 19 and y is 14 from the calculator. So that's the point of intersection of 19, 14. Part B, find the equation of C. Okay, well, we've done the hard work of finding what the coordinates are. So it's x minus 7 squared and y minus 9 all squared is r squared. So what's that going to be? Plus that's just a bit of Pythagoras now, isn't it? That's going to get me what r is 13. Therefore, we conclude, then we get equals 13 squared. Okay. Moving on. Question 7. A and B are two positive irrational numbers. The sum of A and B is rational. The product of A and B is rational. Caroline is trying to prove this. Identify the mistake. Well, I think the mistake is in here, in step 1, because 1 over A and 1 over B is A plus B over AB, not 2 over AB. Not that one. Okay. Right, on the correct version of the proof. Okay. So we need to do exactly what I just did there. A plus B over AB, combining the fractions together. That's basic GCSE stuff. These two here are both rational. So 1 over A and 1 over B is rational. It's a little bit like a contradiction proof, which is what they get you to do here. Prove by contradiction that the difference of any rational number and any irrational number is indeed irrational. So we're going to assume the opposite. So assume that the difference between a rational and an irrational is irrational. So A over B minus X is some C over D, where A, B, C, and D are all integers. We should be familiar with a set of integers by now. And that B and D cannot be 0, where X has to be irrational. Rearrange for X, that's A over B minus C over D, which is AD minus BC over BD, which is rational. Which will then give us the contradiction that we want. So X is rational. So the difference is indeed irrational. That will end the proof. On to question 8. I've got x is t squared, y equals 2t with a domain of t. Very good. Find a Cartesian equation in y squared. This is very, very bog standard. So y squared will be 2t squared, which is 4t squared. But we know what t squared is. That's just x, so that's going to end up being 4x. Very, very straightforward for 2 marks there. And then we get this beast. At the point A lies on the curve where t equals a. The tangent to the curve at A is at an angle of theta to a line through A parallel to the x-axis. The point B has coordinate 1, 0. The line is at an angle phi to the x-axis. Okay. So by considering the grain of the curve, show that tan theta is 1 divided by A. Fair, I think. I mean, it's not fair, but you know what I mean. dy by dx is dy by dt times dt by dx by the chain rule. So I'm going to do some parametric differentiation, which is what, 2 over 2t? Which is 1 over t. At t equals a, dy by dx will be 1 over a, but we know that the gradient of a line is the same as tan of an angle. Therefore, tan theta is just 1 over 8. So key facts that, and I think that is so important, I'm going to highlight it because I think that's one of the most important rules in parametric equations. Find tan theta in terms of A. Okay. Not tan theta, tan phi rather. So we've got the coordinates of A, which were A squared comma 2A. And we have the coordinates of B were 1, 0. Okay. So the gradient of AB, so the gradient of A to B was just 2A over A squared minus 1. Okay, therefore tan of phi, you should really be putting the line on the top of phi, which is going to be 2A over A squared minus 1. Okay, so it's using that same fact. Show that tan 2 theta is tan phi. Well, we know tan 2 theta is 2 tan theta over 1 minus tan squared theta. That's one of the ones that I expect everyone to remember, which is the same as 2 over A divided by 1 minus 1 over A squared, which is exactly the same as we can see there's 2A over A squared minus 1, which is indeed tan of phi. Okay. So I think we're coming to the end of the pure now, aren't we? With question number 9. A cylinder is to be cut out of the circular face of a solid hemisphere. The cylinder and the hemisphere have the same axis of symmetry. Okay. We're going to show the volume of this. So it's the classic rates of change problem, isn't it, that we've seen in the past. It's probably worth drawing a quick diagram just to see what we're looking at here. We've got the height of the thing here. Okay. We've got some distance r, we've got some little distance r. Okay, so we know that h squared plus r squared will end up giving me big R squared, i.e. R squared is going to be what's R squared minus H squared. Cool. We know that the V is going to be pi R squared H. That's one of the things you have to remember. Which is then going to give you pi times R squared minus H squared times by H, which is just pi R squared H minus pi H cubed. Okay. Fairly straightforward, that really, when you draw a diagram. That's why I recommend all my students to draw a diagram, because it does help a lot. dv by dh is going to be derivative of that, which was, what was it, in respect to h, which will be pi r cubed minus 3 pi h squared. We're going to set it equal to 0, because it's going to be a stationary point, i.e. the r squared will be, what's that going to be there? 3h squared, is it? Yeah. i.e. h is going to be r divided by root 3. So the max v would just be pi r squared times r over root 3 minus pi times r divided by root 3 cubed, which is 2 root 3 pi r cubed divided by 9. The second derivative in respect to h is just minus 6 pi h. At h is r over root 3. The second derivative is going to be negative. So a max volume. Cool. Right, so we're on to mechanics now, as I thought I were. So, we've got a vehicle at a constant speed, okay. Well, it's at a constant speed, so that means that the acceleration will not... the acceleration will be 0, won't it? It's on a straight road, okay. So the vehicle's not accelerating, that's rubbish. The vehicle's driving force exceeded, no, it doesn't, definitely not. The roll's not acting on the force will be 0. Yes, definitely. The resultant force acting on the vehicle is dependent on its mass. No, because that will become under F equals ma, but it's not accelerating, so that's rubbish. So it must be the third one there. A number of forces act on a particle. Okay. So we want to calculate the total of the other forces, such that the resultant is this. So 6 minus 3 has got to be 8 minus 5 plus some vector. Okay. How do we get there? Well, I need to minus 2 from the top and add 2 to the bottom. So that's going to be this one here. Just that little equation helps you sort a lot of things out. Okay. It's only 1 mark. You don't have to do much working for it at all. So we need to look at these being parallel. Okay, well, the only way that they are parallel is when 8 minus 12 has to be some multiple lambda of minus 6, 9. That's the only way that's going to work, isn't it? So yeah, A must be minus 6 for that to work, because it's going to be parallel to it. So you need some multiple lambda for that to work. And where your lambda there is going to be minus 4/3. Isn't it? That's the only way that will work. You just keep trying them till they work. Okay, moments. Very good. I do like a moments question sometimes. Okay, so we need to consider the weight of the thing. Okay, let's do that. We've got distances. We've got a weight of 4g. It is uniform, so we take that in the centre, don't we? So I always take moments about a particular point and then find W pretty quickly. So what's the best way to do that? Let's take moments about C. So that is equal to 0. I take clockwise as negative, as we all should do. So that's going to be 2W. That's going to be pulling it that way around, like that way, innit? So that's going to be anti-clockwise, which is positive, and this bit is going to be 1.5 meters, isn't it? So that's going to be minus 1.5 times 4g, so that'll equal to 0. That's going to give me that W is what, 3g? Yeah, 3g. Very good. Explain how I use the fact that the rod is uniform. So the weight is just an easy 1 mark, acts at the centre. Right, so find the exact speed. Now, because it says speed, that is the modulus of velocity. So when we differentiate this in respect to time, we're going to get what? We're going to get 3t squared minus 10t and 8 minus 2t. We've differentiated it. We need to sub in that t equals 2, which is going to get me the vector minus 8, 4. But we want the speed, so we need to find the modulus of that vector. Now, you can do a quick diagram, or you can just do 8 squared plus 4 squared, if you like, which is going to give you 64 and 16, which is going to give you 8c, which is 4√5 meters per second. I know I'm doing these in my head. I really apologise for that if I do make any errors. Let's keep going. Valley claims that the magnitude of the acceleration will never be 0. Determine if it'll be correct. Well, the acceleration is going to be 6t minus 10 and minus 2. Now, the modulus of the acceleration will be the square root of 6t minus 10 squared plus 2 squared. So the modulus of the acceleration is greater than or equal to 2. So never 0. So incorrect. Something along those lines. We've got a particle doing a graph thing. Okay. Use trapezium rule. Not seen trapezium rule in a while, but it is pure mechanics, so we will take it. We've got the height of 20, haven't we, for all the strips. Okay, so we need to just literally sub them all in, don't we? So y0 is going to be what? So it's initially starting from t is 20. We'll have to look at the graph, which is t is 20. It's going to be about here, isn't it? Which is what? 131. Y1, the next term, which will be at 40, which is at 140. And then we go to Y2, which is going to be at 60 seconds, which is 120. And we've got Y3, which is going to be here at 80. And then we've got Y4, which is 100 seconds inclusive, so it's going to be 0 there. Okay, so the area that we want is height divided by 2 of the first and the last plus 2 lots of the in-betweeners, which is 8110 according to my calculator. That one I have to do in the calculator, not in my head. Over the same time period can be modeled by a quadratic. An alternative estimate, integrate between t is 20 and t equals 100. Sure, that'll work. We've got 2 particles released from rest. It's probably worth drawing a quick diagram here, just to see what's going on. We've got a particle dropped over some height, and we've got a particle also dropping with some kh, okay, where k is between, well, k has to be between 0 and 1. Okay, so we've got s is ut plus half at squared. Oh, that's in the formula, but you can just nick it. So the height is going to be half g t squared. Is that? So it is. So that's going to be, the height is, what's that going to be? 25g over 2. So multiplying by k, kh is 25 kg over 2. Right? And if I do that over here for kh, which is going to be 1/2 g t1 minus t squared. That should be t1, I apologise for that. That should be t1. So that's going to be 1/2 g of s minus t. Well, that should be a 5, sorry, squared. So we've got kh for both of them now. So we've got 25 kg over 2 is 1/2 g 5 minus t squared. So we got what's 25k is 5 minus t all squared. So that's going to be that 5 root k is 5 minus t. It's going to be positive, remember. So t is going to be 5 minus 5 root k. But I can just factor a 5 out of that, and that's going to get me 1 minus root k. Lovely. We're almost there. We are nearly there. Question number 17. Out of 19, so we're getting there. I apologise if I'm going a bit quick for you, but you can always pause the video. Right, let's see what we've got. V equals triple t, which means that t is v minus u divided by a, which is 0 minus u sine theta, the component of that, divided by minus g, the acceleration. Because I'm going upwards as positive, so it's going to be negative, which is going to be u sine theta divided by g. the range of the thing is going to be just the distance, which is ut cosine theta, which is just 2u squared sine theta cos theta over g, which is the same as u squared sine 2 theta divided by g. That's not the end of the problem, because we know that d has to be less than or equal to u squared sine 2 theta over g. So we get sine 2 theta is going to be greater than or equal to dg over u squared. Cool. 6 marks for that, that's a gift. If you know your formula, it is anyway. Ooh, nice. I can actually draw on the diagram. That's helpful, isn't it? So, always have tensions going in that direction, just as a general thought. That's going to be 2g downwards. The component of that, which will just be r. Then we've got the weight of the thing is 0.2g. Then you got these components here. You've got the component of friction, mu r. You've got the component of the weight as well. That's pretty much everything we need. We just need to resolve that way and that way using f equals ma. That's going to be t minus mu r. Make sure I look at the diagram. Minus component of the way 0.2g sine theta is 0.2 times this thing here, 543 over 625 g. So if I resolve just upwards on the other one, which is going to be that 2g minus t is 2 lots of 543 over 625 g. The best thing to do to get rid of the tension is to add them together, so that's going to be what, 0.2g minus mu r minus 0.2g sine theta. I am going a bit quick, I do apologise if I am. 2.2 of 543 over 625g. So these questions are a lot more intense than they are in Excel, for the ones I've done for Excel, which is going to be 0.2 minus mu times 0.2 cosine theta. So we want to find the coefficient of friction, okay. Minus 0.2 sine theta is going to be 2.2 times 543 over 625. We're almost there. You can actually just go straight to your calculator at this point. We're given that sine theta is somewhere, are we? We're given tan theta is 7 over 24. Okay, so tan theta will be opposite over the adjacent rather. So that one's going to be 25. So we want to find what sine theta and cos theta are. So cos theta is just going to be 24 over 25, isn't it? That could be 7 over 25. Cool. So we can just find mu by dividing everything over. So it's going to be 2.2 times 543,625 minus 0.2 plus 0.2 lots of 7 over 25 divided by 0.2 24 over 25, and I hope that gives me 0.17, which it does. Cool. Do enjoy these mechanics questions from time to time. Okay, use G as 9.81, reading the question carefully. Find the distance and where it breaks. Okay, so this is your classic v squared is u squared plus 2as problem. So we can find what s is pretty quickly by doing v squared minus u squared over 2a. So s is just 0 minus 0.5 squared over minus 2 lots of mu g cosine theta plus g sine theta. Sub everything in the form we had before, and you get apparently 0.0288 according to my calculator. I don't know if that's right, but that's what I get. Because say it's when the string breaks, I'll make sure we're taking G as 9.81. But apart from that, just go along with it. Let's take an assumption that could affect the validity. Okay, so for example, A doesn't reach the pulley. before going to rest. That'll do. Differential equations, nice. So we're given the acceleration as minus 0.1 v squared. I'll just write that down for myself so I've got it. So dv by dt is minus 0.1 v squared by using what a is. The acceleration is just the derivative of velocity in respect to time. I.e., that tells me that the integral of 1 over v squared dv, solving by separation of variables, is going to be the integral of minus 0.1 times dt. So minus v to the minus 1 is going to be minus 0.1 t plus c. Yeah, so v is 1 over 0.1 t plus c. At t is 0, you're going to get c is minus a quarter, aren't you, there? So therefore v is 1 over 0.1 t plus minus a quarter, rather. You can multiply by 4 if you wish as well, so you get what, 20 over 5 plus 2t, which gives you what you want. Nice. Nice question, that. Finally, acceleration of the particle when t is 5.5. That's a bit of a gift because we just want v when t is 5.5, which is going to give you 20 over 5 plus 2, that's a 5.5, which is 1.25. However, we want to sub that in. I'll do that really quickly. On the calculator, that gives you minus 0.15625, and because it's exact, I'm not rounding out to 3 significant figures. End of questions. So guys, if you want to see this paper in full for yourself, as I say, it is the June 2020 paper for AQA level maths paper 2. Of course, I'm not going to sign it for obvious reasons, but yeah, there you go, and I hope you enjoyed, and I will see you in the next one. I'm out of here.